Greetings everyone. Welcome to the channel Mentor Talks. So in our previous session we were discussing about one fine topic, that was linear programming problems. So there we have seen what was the concept behind that topic. So in this session we will try to gain more insight about the same topic. So we'll be just looking into some of the good examples that might help you to understand the concept on a better way. So if you haven't seen the previous video, please go and see that video because this is going to be a continuation of your previous video. Alright, so let's try to understand this with the help of one fine example. So here we got one question. So if you want, you can just copy down the question, or maybe if you want, you can just pause the lecture, and after writing that you can resume the lecture. Okay, now coming to the question, this question is regarding the Two Minds company. See, when you get any question on LPP, there is one thing which you should be very careful about. That is, see, they won't give you the objective functions and they won't give you the constraints. It is actually your headache to frame the constraints out of the given data. So you should be very good at reading and analyzing the information which is given on the question. And based on those information, you should be able to produce those constraints. So that is very crucial. Because if you are deriving your constraints in a wrong way, your entire calculation, whatever you are doing after that, it is going to be wrong only. So there is no point in continuing. So make sure you are reading the question completely, carefully you are reading the whole question and you are able to understand that question properly. Then only you will be able to frame your constraints. Alright. So let's try to understand what here they are trying to convey. So here there is a company, that is Two Minds company, and this company owns two mines, that is mine A and mine B, and both the mines produces some kind of ore. Ore means, see, it is a mineral from which we be extracting the metals. It could be anything, and we need to understand that these two mines, they produces three qualities or three grades of ores that is being mentioned here, like high grade, medium grade and low grade, and their production in tons per day is also given. Like you can see that mine A produces 6 tons per day of high grade ore and 3 tons per day of medium grade ore, and respectively others also. So that is the initial part. And here if you look into this part, this column indicates cost function, that is how much cost is involved in operating these mines for each day. Say for example, the mine A, for running or operating mine A per day it requires 180 pounds, and for operating mine B per day it requires 160 pounds. So those were the initial information which was given on the question. Now we look into the last part of the question. There they are trying to ask, like, how many days per week should each mine be operated to fulfill this contract. So here there is one contract, or here there is one condition that has to be satisfied by this company. So this company is liable to give minimum of 12 tons of high grade ore, 8 tons of medium grade ore and 24 tons of low grade ore per week. So there is a delivery contract. This company is supposed to deliver minimum this much amount of ores of respective grades to someone else. So that is one condition in our terms, which we can call as constraint. Now we look at the last part. For delivering this contract, for meeting this constraint, how many days in a week these mines should operate? That is the question part. So I hope now you got an overall idea what they are trying to convey. So let's try to find out what are your constraints, and we also need to frame your objective function. See, always start by framing your objective function, because based on objective function only we'll be proceeding. Now, here try to identify your objective function. What is objective function? It is of course a company. So company has to make either profit or it should minimize cost. So clearly here they have mentioned the cost. So since the cost is mentioned here our objective function is cost. And we know optimization for the cost means we are trying to minimize the cost. Alright, fine. So now we need to see that what are the variables which should be influencing the cost. So whatever variables which are governing those costs, that should be assigned some values or some variables. Are you getting? Say here you can see that cost per day is given. That is a title. That means if the mine A operates for 1 day, the cost involved is like 180 pounds. So you need to understand that the cost increases as the number of days increases. That is, the number of days is a parameter which influences the cost function. So definitely I should represent number of days as my variable, because the variable which is influencing here cost function is the number of days for which that your mines are operating. So here you can confirm that by looking into the last part of the question again. How many days per week should each mine operate? They are asking like in a week, how many days each of the mine should operate so that they could satisfy this contract. So I hope this part is clear for you. So here we have our objective function, that is cost function, which we need to minimize. And the cost function is influenced by certain governing factors, that is the number of working days in a week. So we are going to consider our variable as number of working days. So that is our first assumption. So let me write that. Okay. Let the number of working days number of working days, we have two mines. So the number of working days, mine A, the first mine, operates in a week. Mine A operates in a week. Okay, that we can take as X days. So I'm just assuming that the number of days the mine A operates in a week is X days. That means out of this many days, X days it is working. And here you should consider this part also. Weekends are exempted. Weekends are exempted means Sundays and Saturdays, that though during those days your mines won't work. So the number of working days that mine A operates is like X days. Similarly, I'm not writing the same thing. Let the number of working days mine B, okay, mine B operates in a week, that I can assume as Y days. So here X and Y are my governing variables which would actually influence my cost function. So let's try to write my objective function. Here what you can see is the mine A. The mine A is working for X days in a week, and the cost spent on operating this mine A for 1 day, that is per day, is 180 pounds. So for 1 day it is 180 pounds. So like that this mine is going to work for like X days. So the total cost which is indulged or which is required for running this or for operating this mine A for 180 days is going to be 180 into X, that is 180X. Similarly, mine B, it is actually working for like Y days in a week, and for operating that mine B per day we require a cost of 160 pounds. So the total cost incurred in operating the mine B is 160Y. So 180X plus 160Y, that is your cost function. I hope that is clear, because we are trying to find out what is the total cost incurred by incurred for operating mine A and mine B in a week. All right, so let's write that. We'll just write here. So we are trying to write our objective function. Now this is very important. Make sure you're understanding this properly and you're writing it correctly. Okay, so let's write our objective function. So here objective function is actually cost function only. That means we are trying to find out what is the cost incurred in operating these mines for a week. So X days mine A is working. So the cost involved in that case is 180X plus Y days mine B is working. So in that case the cost involved in running mine or operating mine B is 160Y. So therefore you can see that our cost function, if you want you can represent it by any variable. Let's say we can use a variable Z or something. Okay, so Z is your cost function. So Z is represented by 180X plus 160Y, that is your cost function. And we know that when we try to optimize this, we are ultimately trying to minimize this function. So somehow we need to minimize this function. That means you have to allocate your X and Y in such a way that the cost function should be minimum. Okay, so this question I'm just telling you how to write the constraints, only that part is going to be taken care. So now we know what is objective function. That part is clear. So let's look into the constraints because that is also equally important. Now, so we would just see what are the various constraints which is being mentioned. Now, what is the first constraint? The constraint or the condition on this problem is this company is supposed to deliver minimum this much quantities of different grades of ore per week. Say for example, if I consider the high grade ore, the company is supposed to deliver or provide a smelting plant with 12 tons. So minimum amount of the ore that should be delivered, which is of the high quality or high grade, is 12 tons. Now, how would I write this as a constraint? It's very simple. We know that production, that is tons per day. In one day, this high grade of ore produced by company A is 6 tons. Okay, in one day, this company A or the mine A produces 6 tons of ores, 6 tons of high grade ores. So, like that, company A is working for X days in a week. So the total amount of high grade ore which is produced by the company A is 6x. Similarly, this mine B, it is producing 1 ton of high grade ore in one day. So like that it is working for Y days. So this 6 and 1 we can use to form your constraints. So let's see how do you write your constraints. So you should know that the minimum value which you require in this case is 12 tons. So which means if I try to write this as an objective function, not objective function, if I try to write this as a constraint, I'm trying to write this as my constraint. My first constraint is what is the minimum amount of delivery of high grade ore? 6 tons per day of the ore from the mine A. That is, mine A is working for X days. So 6x, 6 into x, plus from the mine B, 1 ton should be delivered, and this mine B is working for Y days. So 6x plus 1y. This is the production of high grade ore from these two mines in a week. Now this production should be minimum equal to 12. That means this production should be either equal to 12 or greater than 12. So if I write this, I can write that like this: greater than or equal to 12. This is an inequality. So what they are trying to say is, in a week, from both the mines, that is mine A and mine B, should produce 12 tons or more than 12 tons of high grade ore. That is 6 tons from the mine A and 1 tons from the mine B. Like that it is working for X days and Y days. So that's how you frame your first constraint. Similarly, you look into your second constraint, you could use the same logic. Now if you look into the second part, you can see that we need minimum of 8 tons of medium grade. That is, this medium grade, that is 3x which is produced by mine A and 1y which is produced by mine B, that should be minimum equal to 8 ton. That means it should be 8 ton or more than 8 tons. So how would I write my next equation? So next constraint, it is going to be like the same logic only, 3x. Alright, so I can write 3x. Now plus 3x means this is the medium grade ore which is being produced in tons by mining, plus 1y. Here also 1y only. 1y is the medium grade ore produced by the mine B. So 3x plus 1y. This is the production in tons of mines, medium grade mine produced by these two companies in a week. Now this should be minimum equal to 8. That means I can write this value should be greater than or equal to 8. See, whenever we mention or condition as a minimum quantity, only thing is you should not get your production below the minimum. But you can always produce more than that. That's why we are using the symbol greater than or equal to. Now the same logic we can use for the third case also. Now that is a low grade ore. Here we require like 24 tons of low grade. So minimum quantity which is required is 24 tons. So that also could be converted into the next equation. So here it is like 4 tons per day. Like that it is working for X days. So 4x. I would write here. Okay. So like that it is working for 4x. Plus the second mine, that is mine B, is working for Y days. and one day it is producing 6 tons. So 6 into y, 6y. Now this quantity should be greater than or equal to, there it is being said that minimum we require 24 tons, that is 24. So these are our major constraints which are mentioned here on this question. But you should not jump into any conclusions. You should read your question carefully again and again so that you won't miss anything. Now here look at this part. How many days per week should each mine be operated to fulfill the smelting plant contract? Inside the bracket something is mentioned. What is that? Weekends are exempted. That means these mines are not going to operate on weekends. So weekends means Saturdays and Sundays. So in a week we got 7 days. Out of these 7 days, these mines would be open only for maximum of 5 days. We cannot open or operate these mines on those weekends. So that even that is a constraint. That is also has to be written. We know that X is the number of working days of mine A and Y is the number of working days of mine B in a week. So here X should not be greater than 5. The maximum value of X, that means the maximum number of days mine A could operate is 5. Similarly, the maximum number of days the mine B could operate, that is also 5. So this could be written as my next constraint, that is X should not be greater than 5. That means in other words I can write X should be less than or equal to 5. That is the number of working days of mine A should be either equal to 5 or less than 5. Similarly, the number of working days of mine B should be either equal to 5 or less than 5. So Y should be less than or equal to 5. So these are also our constraints. So don't skip them, because if you skip these two constraints, you're going to get a different answer. So that's why I'm repeatedly saying read the question again and again. Again, this is not complete. In our previous session, I have told you something like non-negative constraints. Certain variables will not be negative under any conditions. Say, here the variables which we are considering is days only. Can the days be negative? See, if we want, we can just keep one mine shut down. That means we are not opening or we are not operating one mine. That is a mine A is not at all operated. Even though one mine is not at all operated, the minimum value it could take is 0. That means X or Y, the number of minimum days of working of any of these mines, that minimum value is going to be 0 only. You would never get negative values. So from that, you can say that this X value should be always greater than or equal to 0. That means it is equal to 0 or a positive number. Similarly, Y value should be also greater than or equal to 0. So that could be written here. X greater than or equal to 0 and Y greater than or equal to 0. These two constraints, as I was telling you on the prior case, we can call it as non-negative constraints. The constraints which will not be negative under any case. Non-negative constraints. So only this much part I want to detail regarding these questions, because what I want to convey is how do you write your objective functions and how do you write your constraints. Only that much I want to mention from this question. So we will just go through this question one more time, because some of you might have some doubts. So here there are like one company is there. This company owns 2 mines, that is mine A and mine B. And what we have assumed is like this mine A is operating for X days in a week and mine B is operating for Y days in a week. So we are considering our objective function as a cost function. We need to minimize our cost function. So for operating this mine A, it requires 180 pounds per day. So mine A is working for like X days. So 180X, that is the total cost for mine A. And mine B is working for Y days. So 160Y. So our cost function would be 180X plus 160Y. Now comes to various constraints. The first constraint is like this company is supposed to deliver 12 tons of high grade ore. That is 6x plus 1y should be greater than or equal to 12. Similarly, 3x plus 1y should be greater than or equal to 8. And here 4x plus 6y, that should be greater than or equal to 24 tons. So those were the initial part. And it is being also mentioned that these mines are not going to operate on weekends. That means the maximum number of days these mines could work is 5 only. So x should be less than or equal to 5 and y should be also less than or equal to 5. And we also know that the number of days will not be negative under any circumstances. So both x and y, they are going to be greater than or equal to 0. So this is how you write objective functions and constraints for a simple question. Okay, so I hope you understood this. In our next question, we would see that once you get the constraints, how do you solve that constraints to get the optimum solution? So that's it. Thank you all for your patient listening.